All right, I wanted to talk about the probability formulas from section 3.1, and I just stole them here and put them here, blew them up a bit for us. But there are some kind of basics of probability that you may have learned like a while back that we're going to be using here. And there's this fundamental part of counting, and sometimes it's easier to count like successes and failures and those kinds of things than to compare the probabilities and use these formulas. So I want to go over these formulas because they're important, and then also show you some ways that I use them, and hopefully some ways to think about it that'll bring a little bit more clarity if you're struggling here on these ones. Anyway, so a conditional probability, that's this guy right here, and we read this, the probability of B given A. So this is the probability that B happens given that A has happened. So A has to happen and then B has to happen, but B happens given that we already know that A happens. Maybe a little bit confusing, but it's different than just the probability that both of them happen. So here, the probability of A and B, that's the probability that both of these things happen. So we take that and we divide by the probability that A happens. So this is the probability of B given A, and if we take this same thing and just kind of multiply it by this, we get the AND here happening. So the AND event and the conditional probability are really the same kind of formula. The probability that A and B happen is the probability that A happens multiplied by the probability that B happened given that A happened. So a little different here. We have a slight change. Oh, no. Anyway. And then next, the probability that OR, so an OR event. So A or B is more inclusive. So it's the probability that A happens, and we add the probability that B happens, and then we subtract the probability that they both happen. So that's kind of a unique one. And then we have the complement of an event. Some questions, it's actually easier to find out when something didn't happen, or when something didn't happen by finding out when it did happen and then just using subtraction. We know that all the probabilities add up to 1. So if we take the probability that something did happen and subtract that from 1, we can get the probability that it didn't happen. And that's what this complement is all about. So I'm going to grab a pen here and just see. Sometimes, well, slide that back over. Try grabbing the pen again. Sometimes it's kind of easier to think of it as a little Venn diagram. So we have A here and B here. So these are the probabilities, and if I just grab a different color, the probability that A and B happen, that's this region right here. So that's all of the intersection where A happens and B happens. And technically, when we have a probability thing like this, we actually have like a universal set. This is our sample space, all the things that could occur. So A happens here. I'm pointing with the stylus, doesn't really work. A happens here. Okay, back to this maybe. Sorry. The probability that A happens is in this region right here. The probability that B happens is in this region right here. A and B, this intersection that I've highlighted. And then A or B is really like this region, the middle, and this region. All these here. You can see here my ugly coloring job. And so that's why we end up with the probability of A plus the probability of B. But then notice we've double counted this middle region. So our formula ends up being the probability of A plus the probability of B minus the probability of A and B. So, okay, little questions, maybe not as good as I hoped it would go, but let's look at some questions here. A geneticist conducts an experiment with peas. One sample of offspring consists of 467 green peas and 148 yellow peas. Based on the results, calculate the probability of getting an offspring of a pea that is green. So I'm going to just take a snip of this. And I'm going to use Excel. I'm trying to get you to use this as a tool, and so that's why I'm doing this here, partly because I'm showing you. Now, I do understand it may be actually easier to use a different tool, but we're going to need to use Excel, and so we want to kind of get good at using it. I'm going to zoom in a little bit. I believe that's question 2. Yeah, section 3.1, question 2. Okay, so With probabilities, we have here some things. We've got green. There are 467 of those. We've got yellow. And we've got 148 of those. And so we have two parts. It's always kind of nice to know what the total is. I'll just let Excel do the sum for us. Sum, and grab these things. So here we've got it, and we just used the sum function. There. We typed in the other one because that's sort of the data that we were given. Now, we are looking for the probability of an offspring P that is green. So our greens are our successes. So the probability of a green, and I'm going to just call that capital G. We take the number of successes, that's the green P's, and divide by the total. Now this is 75935, and if I round that to 4 decimal places, I get 759 and 4 there. Now one thing to note, if you're using this Excel to do your work, and even if you're not, you should be using the unrounded results as you do the work and rounding your final answer. So go here, 0.7594 I think it was. Phew, got it. Okay, so we have some other probabilities here, and they have a little bit more background knowledge. This question here can be a little bit problematic. It involves a little bit of geometry. So the area of the square, you have to use the information given to find the area of the square, and then also the area of the circle. And then the probability that you get in this yellow region is the area of the circle divided by the area of the square. So let me just walk through this one, I suppose, since I stopped here. I can't remember which question that was. Let's say it was question 6. Go back and check. See how we did. Question 5. Darn it. Okay. So question 5. Edit that. Go here. And I'm going to zoom in just a little bit. One thing nice here is occasionally you can get a draw feature going if you want. We don't have one here active, and I feel like if I went and did it, it would be hard to find. Anyway, but usually I do. That's kind of interesting. So, finding the area of the square. The side length is 8 centimeters, a square, length times width. So the area of the square is equal to, we basically have 8, and we need to do 8 times 8, or we square it, so we can use the little caret in the 2. And that's the area of the square. Now the area of the circle is pi times the radius squared. And Excel can actually do pi if I start typing in the function here. And what's kind of weird is you just want to close it. And then I want to do times the radius squared. Well, the side length is 8, so the radius is 4, and then I square it. Uh, 16 times 3 is about 48, so that's pretty reasonable. So then our probability here that we're looking for, the yellow, is going to be equal to the area of the circle divided by the area of the square. And I might want to see about rounding that. It looks like it rounded it correctly there. 0.7854. So just a couple of questions. I want to give you some tools, talk a little bit about the basics, and then I'm going to come back and do a few more examples out of section 3.1. Please let me know if you have any questions. Thanks for watching.